Hello everyone. Let us start with the part 3 of 2024 ECE Polytechnic lecture question paper conducted by APPSC. 61st question. TE10 mode is propagating through rectangular waveguide. The tangential electric field component at the left and right vertical walls are dash and dash respectively. So the waveguide is made up of perfect conductors. The walls of waveguide is made up of perfect conductors. In a rectangular waveguide, the walls are located at x is equal to 0, that is left side wall, and x is equal to a, the right side wall. The tangential component of electric field is 0, must be 0 at x is equal to 0 and x is equal to a. At both the walls, the tangential component of electric field is 0 since electric field is continuous at the boundary interface of conductors. So ET1 is equal to ET2. On the top of conductor, tangential component of electric field is 0. So that is ET1 is 0. So answer is 0 and 0. The walls of waveguide are made up of perfect conductors. The tangential component of electric field Ex and Ez must be 0 at the left and right walls of rectangular waveguide. This condition is direct consequence of conductor boundary conditions. So direct consequence of conductor boundary conditions, that is the boundary conditions at the conducting surface require electric field to be perpendicular to the surface. At the conductor boundary conditions, electric field is perpendicular to the surface. Electric field component exists in perpendicular to the surface, but the tangential component of electric field is 0. The tangential component of electric field is 0 on both the walls. Correct option is 1. Next question. Rectangular waveguide filled with air has a dimension of 1.5 centimeter and 1 centimeter operating in TE10 mode. What is the cutoff frequency? So in the question they have given rectangular waveguide. The waveguide is rectangular waveguide and it is operating in TE10 mode. For a rectangular waveguide, TE10 mode is a dominant mode. TE10 mode is a dominant mode for a rectangular waveguide. Next, the dominant mode is, it is a fundamental mode or a lower order mode in which attenuation is minimum. So dominant mode is the mode with lowest cutoff frequency or the mode with highest cutoff wavelength. The cutoff frequency formula is Fc is equal to 1 by 2 pi square root of 1 by mu epsilon square root of m pi by a whole square plus n pi by b whole square. This is the formula for cutoff frequency Fc in a waveguide. So the cutoff frequency is the operating frequency below which attenuation occurs and above which propagation takes place. Simply, waveguide acts like a high pass filter. In the question, they have given TE10 mode, that is dominant mode. So for TE10 mode, the cutoff frequency is C by 2A, where A and B are the dimensions of waveguide. A is a wider dimension and B is a narrow dimension. C is velocity of light in free space, that is 3 into 10 power 8 meters per second. In the question they have given, it is filled with air. So now cutoff frequency Fc is 3 into 10 power 8 by 2 into a. Wider dimension is 1.5 centimeter. So convert it into meters, 10 power minus 2. The answer is 10 gigahertz. So first option is correct. Next question. Identify the following antenna. So the antenna given is there are two conductors, each of lambda by 4 length. So the total length is lambda by 2. So the given antenna is half wave dipole antenna, because for half wave dipole antenna the radiation resistance is 73 ohms. So let us see some properties regarding half wave dipole antenna. So for half wave dipole antenna, the length of half wave dipole antenna is 1 by 2 times of wavelength, half of the electrical wavelength. Antenna having length equal to half of its wavelength. So half wave dipole antenna is antenna having length equal to half of its wavelength at the frequency of operation. So for quarter wave monopole antenna, the length of antenna is 1 by 4th 1 by 4th of its wavelength at the operating frequency of operation. Next, folded dipole antenna is formed by combining two half wave dipole antennas in parallel orientation. Two half wave dipole antennas, two lambda by 2 dipole antennas connected in parallel combination will result folded dipole antenna. Next, monopole antenna is lambda by 4 antenna with ground plane. So this is lambda by 4 monopole antenna. So the length of the conductor here is lambda by 4, and the antenna is mounted on a conducting surface. So for quarter wave monopole antenna and quarter wave dipole antenna, the structure is single vertical element, two opposite horizontal elements are there. It requires a ground plane. Quarter wave monopole antenna requires ground plane. Ground plane is not required in quarter wave dipole antenna. Size is 1 by 4 of wavelength. Size is 1 by 2 of wavelength. And this is folded dipole lambda by 4 monopole. This is lambda by 4 monopole and lambda by 2 dipole antenna. And this is lambda by 2 dipole antenna. From the question, the correct answer is half wave dipole. Let us see some more points related to half wave dipole. The length of half wave dipole antenna is length of for half wave dipole antenna, length of antenna is lambda by 2. Radiation resistance is 73 ohms. Lambda by 2 centimeters or meters. Radiation resistance is 73 ohms, and directivity of this half wave dipole antenna is 2.15 dBi. Length of each arm. So this is arm length. Length of each arm is lambda by 4, and polarization is linear polarization. If this antenna is mounted vertically, then it will emit vertically polarized waves. If this antenna is horizontal to earth surface, then it emits horizontal polarized waves. Then half power beamwidth for this dipole antenna is 78 degrees. Input impedance of this half wave dipole antenna, that is radiation resistance, is 73 ohms in free space. Half wave dipole antenna is an antenna having length equal to half of its wavelength. Antenna having length equal to half of its wavelength. Monopole antenna is conductor mounted vertically on a ground plane or a reflective surface acting as a counterpoise. Next, quarter wave monopole is a dipole antenna whose length is one fourth of its wavelength. Folded dipole antenna is formed by combining two half wave dipole antennas in parallel orientation. Next. So these are the directivities of different antenna. For short dipole, directivity is 1.5. For lambda by 4 monopole, directivity is 3.28. For half wave dipole, it is 2.15 dB I or 1.64. So directivity here is 1.64. For isotropic antenna, directivity is 1. For hemispherical antenna, directivity is 2. So directivity is defined as the ratio of radiation intensity in given direction from antenna to average radiation intensity in all directions. Next question. The dipole antenna has omnidirectional radiation pattern. The statement is correct. So let us see the radiation pattern of half wave dipole. So this is a horizontal radiation pattern and vertical radiation pattern, and this is three-dimensional radiation pattern of half wave dipole. So three-dimensional radiation pattern is omnidirectional, so donut shape, and its radiation pattern is omnidirectional. So that is radiation in all directions Omnidirectional means radiation in all directions except along the axis. So along the axis, zero radiation except along the axis. So it emits radiation in all directions, but zero radiation along the axis. Radiation pattern of dipole antenna is omnidirectional, that is radiation in all directions except along the dipole axis. So the radiation pattern is donut shaped in 3 dimensions. Maximum radiation pattern is perpendicular to the axis. So radiation pattern is maximum in perpendicular to the axis, and minimum radiation along the axis. Along the axis, radiation is minimum. Radiation is minimum or zero. Perpendicular to the axis, perpendicular to the dipole axis, radiation is maximum. So radiation is maximum for this dipole antenna in perpendicular direction, and minimum along the axis. So that means along the axis there is no radiation, means zero radiation along the ends of dipole. Along the ends of dipole, radiation is zero. Along the ends of dipole, radiation is zero. So statement A is correct. Next statement. So bandwidth is a measure of antenna directivity. So this antenna beam width and directivity are inversely proportional to each other. Narrow the beam width, higher the directivity. Narrow the beam width, say BW, higher the directivity. Directivity D. So wider beam width means lower directivity. So if beam width is wider, lower will be the directivity. So both statements are correct. Next question. So 0% return loss is equivalent to dash of the antenna. So let us see the definition for impedance matching of antenna. So impedance matching of antenna means antenna input impedance matches with the characteristic impedance of transmission line. So if input impedance of antenna matches with the characteristic impedance of transmission line, then it is said to be matching condition, that is antenna impedance Z is equal to characteristics impedance or Z naught of transmission line. Characteristic impedance of transmission line. So various impedance matching techniques are lumped element matching, lambda by 4 transformer, stub matching, and balloon, etc. So this when the antenna impedance is equal to characteristic impedance, then reflection coefficient gamma is 0. So wave is completely propagated. So in this case, signal is completely propagated. Completely propagated. Reflected component, reflected signal is 0. In this case, reflection coefficient gamma is 0. If reflection coefficient gamma is 0, then VSWR, voltage standing wave ratio, is 1. So 0% return loss. So 0% return loss means reflection coefficient 0 is equivalent to dash matching condition of antenna. It is equivalent to matching condition of antenna. So this is 0% return loss. Reflection coefficient is 0. Next question. The radiation pattern in a broadside antenna array is dash of the plane of driven element and has beam width compared to that of unit element. The broadside array is an arrangement in which the radiation pattern is perpendicular to the array axis. So that is constructive interference along the array axis and destructive interference normal to the axis. So broadside array, the radiation pattern is perpendicular to the axis. So that's the first point. So next is radiation pattern of antenna array is narrower compared to the single antenna. So in antenna array, there are more number of antenna elements and the radiation pattern of antenna array is narrower. So beam width is narrow compared to the single antenna beam width because the constructive and destructive interference of signals from multiple elements of array and beam forming and phasing. So this beam forming means relative phases of signals transmitted from each element can be controlled using phase shift which directs energy in specific directions. Next is antenna geometry and element spacing in an array. Increased effective aperture of antenna array is more when compared to the effective aperture area of single antenna, and more number of elements means more directivity. So in antenna arrays, the directivity is proportional to NL by lambda. So this directivity is proportional to number of elements. So directivity D is proportional to number of elements and physical size of the array. So directivity proportional to number of elements and physical size of the array. So as we know that directivity is inversely proportional to beam width. If antenna size is more, directivity is high, beam width is narrower. So beam width is narrower. Correct option is 1. So here beam width is given, definition for beam width and definition for directivity is given. So directivity means is a measure of concentration of radiation pattern in particular direction. Beam width is angular width of radiation pattern at the points when radiated power falls to half of its maximum value. That is angular width at half power points or minus 3 dB points. This beam width is measured in degrees for an antenna. Smaller the beam width, more concentrated the radiation pattern implies more will be the directivity. If beam width is smaller, the radiation pattern is concentrated in particular direction. Beam width is smaller, radiation pattern is concentrated in particular direction implies higher will be the directivity. Next, so directivity is simply how sharply the antenna focus its beam. Narrower the beam means high directivity and broad beam indicates lower directivity. So this beam width and directivity are inversely proportional to each other, and beam width is calculated at half power points, and beam width of array depends on number of elements and physical size of the array. Array has more number of elements, more directivity implies less beam width. Narrower will be the beam width. Next question. Question 67. So log periodic antennas have wider beam width as compared to Aggie antennas. So these log periodic antennas are wider beam antennas. So log periodic antennas are having wider beam width, and Aggie antennas have narrow beam width. Statement P is correct. Next, statement Q. The radiation pattern of end-fire array is same as that of Aggie antenna. So statement Q is also correct. Aggie antennas are designed to have narrow frequency range. Aggie antenna have more directional radiation pattern than log periodic dipole antenna for a given size. So this Aggie antennas have narrow beamwidth means more directivity. So that is Aggie antenna is having more directional radiation pattern. More directional radiation pattern. than log periodic dipole antenna for a given size. AGA antennas are designed for narrow frequency range, while l- log periodic dipole antennas are designed for wide frequency range or broad radiation pattern. For log periodic antennas, the radiation pattern is broad radiation pattern. The radiation pattern of end-fire array antenna is same as the direction of AGI antennas. Statement is correct. Next question. Moving target indicator is a type of, so it is an radar, MTI radar, radio detection and ranging. This MTI is a type of radar system designed to detect and track moving targets while filtering out stationary objects. That is stationary objects, that is ground, building, trees, or stationary clutter is rejected. Here stationary in MTI radar rejects stationary clutter. Stationary clutter is rejected, that is trees, buildings, ground. This MTI radar discriminates moving target against the cluster. So simply this MTI radar distinguish between non-stationary objects from distinguish non-stationary targets from stationary objects. It discriminates moving targets against clutter. Correct option is 1. This MTI radar distinguish between non-stationary targets from stationary targets, or it discriminates the moving target against the clutter. Next question. What is a numerical aperture of optical fiber cable if acceptance angle is 30 degrees? So the numerical aperture describes the light gathering capability or light collecting capability of an optical fiber. Larger the magnitude of numerical aperture, greater the amount of external light the fiber will accept. So generally it is desired to have a large magnitude of numerical aperture. So numerical aperture is sine theta A. Theta A is acceptance angle, sine of theta A, where theta A is acceptance angle given. For the problem they have given acceptance angle theta A is 30 degrees, so sine 30 is 1 by 2, that is 0.5 is a numerical aperture. So correct option is 1. Next question. What is the value of current I in the given circuit? So we know that KCL, Kirchhoff current law, the sum of currents entering and sum of currents leaving in the junction is 0. That is algebraic sum of currents is equal to 0. So this Kirchhoff law KCL is based on the principle of charge conservation. So let us, in this diagram, let us assume, so this is node A, B, C and node D. Let A, B, C are the nodes. So apply KCL at node A. KCL at node A. So that is sum of incoming currents is equal to sum of exit currents. So 50 is equal to 20 plus I1. So I1 is 30 amperes. Similarly, KCL at node D. KCL at node D. So 30 ampere is equal to 120 plus I2. Now current I2 is minus 90 ampere. Apply KCL at node C. So minus I2 minus I plus 15 is equal to 0. So from this current I is equal to 15 minus of minus I2. I2 is minus 90. So that is 105 ampere. Correct option is 4. Next question. Consider the mesh circuit and compute I2 and I3. So first method, so this is method 1. Let us assume V1 be the node voltage at node A, V1 be the node voltage at node A. Apply KCL here, that is V minus 36 by 12 plus V by 6 plus V minus 9 by 5 minus 6 is equal to 0. So upon calculation, we will get node voltage at A is 24 volts. Now current I3 is V minus 9 by 2 plus 3 ohm, 2 ohm plus 3 ohm, that is 3 ampere. Current I2 is 6 plus 36 minus 24 by 12, so that is 7 ampere. So there is one more method. Let us try the same problem with one more method. Apply KVL in loop 1. So method 2, KVL in loop 1. So that is current I1 is 6 ampere. Next, KVL at loop 2. 36 is equal to 12 into I2 minus I1 plus 6 into I2 minus I3. So that is 18 is equal to 3I2 plus I3. Next, KVL at loop 3. KVL means sum of voltages around the closed loop is 0. KCL means sum of entering currents is equal to sum of leaving currents. So KVL is total voltage around closed loop is equal to 0. This KVL is based on law of conservation of energy, where KCL is based on law of conservation of charge. So KVL at loop 3, that is minus 9 is equal to 6 I3 minus I2 plus 3I3 plus 2I3, that is 5I3. So on calculation, minus 9 is equal to 11I3 minus 6I2. Solve equation 2 and equation 3. So this is equation 1. So on solving equation 2 and 3, so we will get current I2 is 7 ampere and current I3 is 3 ampere. So I2 is 7 ampere, I3 is 3 amperes. Next question. So any two-terminal bilateral DC circuit can be replaced by an equivalent circuit consisting of voltage source and series resistor. The complete circuit is replaced with an voltage source and series resistor. So that means the given theorem is Thevenin's theorem. So even Thevenin's theorem, the equivalent circuit consists of voltage source and series resistor. Similarly, in Norton's theorem, the complete circuit is replaced with current source with parallel resistor. So statement of superposition theorem is in any linear active bilateral network having more than one source, the response across any element is sum of responses obtained from the source considered separately, while other sources are replaced by internal resistance. That is, current sources are open circuited, ideal current sources are open circuited, ideal voltage sources are short circuited. This superposition theorem is not applicable for calculating the power responses. Next is reciprocity theorem. So this is a statement of reciprocity theorem. In a linear network, the ratio of voltage excitation to current excitation is unaltered or unchanged when the position of excitation and response. When the position of source and load is interchanged, it represents reciprocity theorem. So this theorem is valid when single independent voltage source or current source is present in the network, and the presence of dependent sources makes a network active. Hence this reciprocity theorem is not applicable. Similarly, this superposition theorem is also not applicable for calculating power responses. This SPT is not applicable for calculating power. So the question is Thevenin's theorem. Equivalent circuit consisting of voltage source and series resistance is Thevenin's theorem. Next question. For maximum power transfer to takes place between source and load, if the source is inductive, then load should be. So from maximum power transfer theorem, To transfer the maximum power from source to load, this load impedance must be equal to the complex conjugate of source impedance. So that is load impedance must be equal to complex conjugate of source impedance, that is ZS. So given this source impedance is inductive. So ZS is inductive. For maximum power transfer, ZL will be capacitive. So ZL will be capacitive for maximum power to transfer to the load. Next question. Three resistors 10 ohm, 15 ohm, 25 ohm are connected in delta network. Identify the resistors in equivalent star network or Y network. So let us see the conversion between delta network to star network. So this is star network having three resistors RA, RB and RC, and delta network having three resistors R1, R2 and R3. In the given question, they have given a delta network with three resistors. R1 is 10 ohm, R1 is 10 ohm, R2 is 15 ohm, and R3 is 25 ohm. So this R1 plus R2 plus R3 is sum of all resistance is 50 ohms. So given delta network with resistance R1, R2 and R3. Now we need to calculate the resistance in star network, that is RA, RB and RC. So this from the formula, RA is R1 R2 by R1 plus R2 plus R3. RB is R1 R3 by R1 plus R2 plus R3. RC is R2 R3 by R1 plus R2 plus R3. Substitute the given values so that RA is R1 R2, so that is 10 into 15 by R1 plus R2 plus R3, so that is 50. Its value is 3 ohms. Similarly, RB is R2 R3, R1 into R3, that is 10 into 25 by 50, so 5 ohm, and RC is 7.5 ohm. So 3 ohm, 3 ohm, 5 ohm. This RA is 3 ohms, RA is 3 ohms, RB is 5 ohms, and RC is 7.5 ohms. The correct option is 1. Next question. Given series RL circuit that draws a current of 1 ampere when connected across a 10 volt source of 49 Hz AC supply, assuming resistance to be 6 ohm, find the inductance in the circuit. So given series RL circuit, so this is series RL circuit with a current flowing is 1 ampere and 10 volt source of 49 Hz source is applied. Now the time constant of series RL circuit is L by R. Next, they have given voltage is 10 volts, voltage is 10 volts, magnitude of voltage is 10, and the current flowing is 1 ampere. Now impedance Z is equal to V by I, that is 10 volts by 1 ampere, that is 10 ohms. In for series RL circuit, Z is equal to R plus J omega L. So mod Z is square root of, so R plus J omega L, that is square root of R square plus omega L whole square. Given resistance is 6 ohms, so from this we will get 10 ohm. Substitute 10 here, square root of R square. So resistance is 6 ohm plus frequency is 49 into L whole square. On calculation we will get L is equal to 25.98 milli Henry. 25.98 milli Henry. So this is omega L. Omega is 2 pi, frequency is 49. Substitute omega here, then we will get L value. Inductance L is 25.98 millihenry. Correct option is 3. Next question. So the power factor is a ratio of average power to apparent power and is a cosine of phase between the voltage and current. The statement is correct. So power factor is the ratio of active power or real power or true power. So power factor is a ratio of, this is a power triangle, active power, real power or true power to Apparent power. So for apparent power, units are volt amperes. Reactive power is volt ampere. Reactive reactance, that is VI sin phi. So power factor is cos phi. Power factor is equal to the ratio of active power or real power or true power to apparent power, VI cos phi by VI. Power factor is a measure of phase between current and voltage waveforms. Power factor is a measure of phase between current and voltage waveforms. So inductor is having lagging power factor. Inductor or inductive load. Inductive load means lagging power factor. Lagging power factor. So that means current lags behind the voltage. Current lags behind the voltage or voltage leads the current. So examples are coils, motors, lamps. Examples of this inductive power factor are coil, motors, etc. So capacitive power factor means leading power factor. Capacitive load is having leading power factor. So that means current leads the voltage. Current leads voltage or voltage lags by current. So example is capacitor banks and synchronous inductors. In the question they have given leading power factor for the inductive load. Statement 1 is wrong, statement 2 is wrong. So neither conclusion follows. So inductive load means lagging power factor, I lags voltage. Examples are coils and motors. Leading power factor means I leads voltage, current leads voltage or voltage lags by current. Examples are capacitor banks and simply capacitors. Capacitive load. So correct option is 4. Next question. In the given figure, the switch K is in first kept in position 1 and steady state is reached. We know that for an inductor, for an inductor, at t is equal to 0 plus at initial stage, it is inductor is open circuited. At t tends to infinity, inductor is short circuited. In steady state, inductor acts like a short circuit. So the steady state, inductor acts like a short circuit. In the initial stage, inductor acts like a open circuit. Given switch is in position 1, so the switch is in position 1 when the inductor is in steady state. So that means this inductor is short circuited. Inductor is short circuited. Now, if inductor is short circuited, now current I flows. This is 100-volt source, 100-volt source, 10 ohm resistor, 15 ohm resistor. Now current I is 100 by 10 plus 15, so that is 4 ampere. 100 by 25 is 4 ampere. Second case, now the switch is moved to position 2. Switch is moved to position 2. So this entire circuit becomes now inoperational, not connected to the inductor. Now inductor starts discharging the charge stored. This is the equivalent circuit of 15 ohms and inductance L Henry. So equivalent circuit we can written as 15 ohms inductor with a series current source. So now current is flowing in this direction. Here current is flowing. This is the direction of current. Switch is connected to position 2. 15 ohms inductance is the value of inductor is 0.5 Henry, and the current source I naught. The time constant for this circuit is time constant tau is equal to L by R. So the inductance value is 0.5 and resistance R is 15 ohms. Resistance R is 15 ohms. Time constant is 1 by 30. Now current in the inductor. So current expression, the expression of current for this LR circuit is, so I final minus I initial e power minus t by tau, where tau is a time constant. So final value of current is 0 minus initial current. So that is 4 ampere. 4 into e power minus t by tau, that is 1 by 30. It will become 30 in the numerator. So the total current is e power minus 30 t ampere. 4 e power minus 30 t ampere. So correct option is 4. Next question. What is the inverse Laplace transform of a signal x of s? So given signal x of s is 1 by s plus 1 by 1 by s plus 2, where the region of convergence is minus 2 less than real part of s less than 1. So real part of s less than 1. So these are the formulas. 1 by s plus a, whose inverse Laplace transform is e power minus at minus of u of minus t, real part of s less than a. If real part of s region of convergence is greater than a, then Laplace transform is inverse Laplace transform is e power minus at u of t. So for causal signal, it is signal is 0 for t less than 0. That is left-handed signal is 0 for t less than t. So causal signal is right-handed signal, but all right-handed signals are not causal. So this is right-handed signal. For t less than t, and left-handed signal is 0 for t greater than t. So in this case, so for real part minus 2 less than real part of s, real part of s greater than a, greater than a or minus a. In this case, this is causal signal. So the region of inverse Laplace transform is minus 1 by s plus a is e power minus 2t into u of t. So this is causal signal plus 1 by s plus 1. For 1 by s plus 1, region of convergence is less than 1. So it is an anti-causal signal or left-handed signal. Inverse Laplace transform is e power minus t minus u of minus t. So the answer is option 3, e power minus of e power minus t u of minus t minus e power minus 2t into u of t. Next question. Find V naught for given circuit assuming zero initial conditions. So this is the voltage V naught of t and input voltage is u of t. So input voltage u of t is 1 by s. This is V naught of s. Let V of s be the node voltage at node A, and it can be written as 1 by Cs, that is 1 by capacitance is 1 by 3s, that is 3 by s ohm, 3 by s ohms. For inductor it is 1 into s ohm, so that is s ohm. This is 5 ohm, 1 ohm. Next, apply KCL at node A. KCL at node A. So the expression is V of s minus 1 by s by 1 plus V of s by 3 by s plus V of s by 5 s into 1 plus 5 ohm is equal to 0. So now V of s is 3 into s plus 5 by s into s square plus 8s plus 18. Now we require output voltage V naught of t. This output voltage V naught of t is, let us assume some current. This is a current I of s. Current I of s. V naught of t is current I of s into into s ohm. 1 into s ohm, that is s ohm. Now I of s is, the expression for I of s is, now I of s is V of s by 5 plus s. V of s by s plus 5. Substitute I of s here. V naught of t is equal to V naught of t is equal to I of s is V of s by 5 plus s into s. Substitute V of s here. Substitute V of s here. Now it will become, so this is V naught of s. Now V naught of s will become 3 by s square plus 8s plus 18. It can be written as 3 by root 2 into root 2 s plus 4 whole square plus root 2 whole square. The expression can be rearranged like this. Now we know that inverse Laplace transform of, or Laplace transform of e power minus at sine omega t u of t is omega by s plus a whole square plus omega square. Now V naught of t, output voltage V naught of t, using this formula, V naught of t is inverse Laplace transform of V naught of s, that is equal to 3 by root 2 e power, a value is minus 4t sine omega t. Omega is sine root t. This is the expression for output voltage V naught of t across 1 ohm, across inductor of 1 Henry. The correct option is 1. Next question. The Laplace transform of x of s of x of t is rational. That is a statement. Conclusions are, ROC is bounded by poles or extends up to unity. The ROC of a rational function or is bounded by poles or extends up to unity. So statement conclusion 1 follows the statement. Next, no poles of x of s are contained in ROC. ROC for a rational transfer function, ROC doesn't contain any poles. For a rational transfer function, ROC consists of strips parallel to j omega axis. Region of convergence consists of strips parallel to the j omega axis. Both these conclusions follow the statement. Some more points related to region of convergence. If signal is of finite duration and absolutely integrable, then region of convergence is ROC is entire S-plane. For rational Laplace transform, ROC doesn't contain any poles. If x of t is left-sided, then ROC is a region in S-plane to the left of the leftmost pole. If x of t is right-handed signal or right-sided signal, then ROC is a region in S-plane to the right of the rightmost pole. If ROC includes j omega axis, then Fourier transform exists. If algebraic expression x of s is same, so that means rational transfer function is same, then Laplace transform are distinguishable only by region of convergence. For same rational transfer function, different Laplace transforms are possible for different region of convergence for different ROCs. Next question. Calculate the Z parameter for a two-port network shown. So given two-port network is a T network. Let us assume these are the ZA, ZB and ZC, where ZA is J40 ohm and ZB is J80 ohms and ZC is minus J minus 160 ohm. Now the Z parameters are open circuit parameters. Z is equal to Z11, Z12, Z21, Z22 is ZA plus ZC, ZC, ZB plus ZC and Z. So Z21 is ZC and Z2 is ZB plus ZC. Now the resultant is J140 minus J160, that is minus J120 ohm minus J160 ohm. ZC is minus J160 ohm, J80 and minus J160, that is minus J80 ohm. So correct one is option 1. Next question. The input and output y of t are related by y of t is equal to x of t minus 3 and x of t is e power j 2t. Conclusions are e power j 2t is eigenfunction, e power j6 is eigenvalue. So let us see the definition of eigenfunction and eigenvalue. If x of t is a input to the system and y of t is system output, tf represents transfer function of the system. A signal is said to be eigenfunction if its output is scalar times of input and that scalar is the eigenvalue. Eigenfunction is a type of input for which output is constant times of input. This is related to eigenfunction and eigenvalue. Now we will calculate the eigenfunction and eigenvalue for the system given. Now y of t is x of t minus 3. Laplace transform of y of t is y of s, that is x of t minus 3 is e power minus s t naught minus s t naught is 3 into x of s. Now y of s by x of s is transfer function, that is transfer function of the system. Its value is e power minus 3s. Also x of t is given, x of t is e power j 2t. Laplace transform of x of t, that is x of s, is equal to Laplace transform of e power j 2t, that is e power at is 1 minus 1 by s minus 2j. Now from 1 transfer function will become e power minus 3s. So in this transfer function e power minus 3s, replace s with 2j. So replace s with 2j. It will become e power minus 3, s is 2j, e power minus 6j. So this e power minus 6j is scalar, that is eigenvalue. So in here they have given e power plus 6j. It is not an eigenvalue, but the eigenvalue is e power minus 6j. And e power j 2t is eigenfunction. This statement is correct. E power j 2t is a eigenfunction. Next question. So related to the properties of Fourier transform. So first given is x of t minus 1. So this is related to time shifting property. Fourier transform of x of t minus t naught is e power minus j omega t naught x of omega. That is x of t minus t1 is e power minus j omega into x of omega. So here t naught value is 1, e power minus j omega into x of 1. So that is a is 3, a represents 3, and t into x of t, that is frequency differentiation. So frequency differentiation. Frequency differentiation for a transform of t into x of t is j d by d omega into x of omega. Next is integration in time. Integral minus infinity to t x of t dt. It is equal to 1 by j omega x of omega plus pi x of 0 delta of omega. So this is integral minus infinity to t. Next, differentiation in time. For a transform of d by dt of x of t is j omega x of omega. So correct option is 4. See some more properties, that is frequency shifting. Fourier transform of x of t e power j omega t is x of omega minus omega naught. Duality property of Fourier transform is, if Fourier transform of small x of t is capital X of t, then Fourier transform of capital X of t is 2 pi small x of minus omega. Next, convolution in time is multiplication in frequency domain. Next, convolution in frequency is multiplication in time domain. Next is conjugate property. X star of t is x star of minus omega. Next question. If x of t and y of t are represented shown in given figure, then what is the Fourier transform of y of t? So given x of t is sinusoidal signal and p of t is a pulse signal, and the representation of pulse signal is p of t, that is sigma n is equal to minus infinity to infinity delta of t minus nts. So if this message signal and pulse signal are multiplied, then y of t we will get. So y of t is x of t into p of t. So x of t and p of t is, this is a pulse signal. So pulse signal. So the resultant is, this is a resultant. Sigma n is equal to minus infinity to infinity x of nts delta of t minus nts. So this is nothing but a sampling property of impulse or multiplication property of impulse. It states that x of t multiplied with time shift of impulse is x of t naught delta of t minus t naught. So time shifting property of, or multiplication property of impulse, or sampling property of impulse. Now apply Fourier transform to signal y of t. For this signal Fourier transform, so that is Fourier transform of y of t is y of omega. So it is 1 by ts sigma n is equal to minus infinity to infinity x of omega minus n omega s. In frequency domain, 1 by ts sigma n is equal to minus infinity to infinity x of f minus n of s. So the correct option is 2. Next question. What is the inverse jet transform of x of z? So suppose if signal is causal signal and infinite duration, then jet transform of a power n u of n is 1 by 1 minus a z inverse. Similarly, for anti-causal signal of infinite duration of minus a power n u of minus n minus 1, the Fourier transform is 1 by 1 minus a z inverse for mod z greater than a. So for causal signal, ROC is region of convergence is exterior to the circle of radius a. This is a region of convergence. From here, the region of convergence will start exterior to the circle of radius a. Similarly, for anti-causal signal is region of convergence is interior to the circle of radius a. So from the given, for the given question, the correct answer is minus a power minus n u of minus n minus 1. It is an anti-causal signal of infinite duration, and the region of convergence is mod z less than a. It is inside the circle of radius a. Next, given statement, uh, in the series RC circuit, capacitor voltage corresponds to only present and past values of voltage source. This, all the differential terms and integral terms corresponds to energy storage elements. Hence energy storage elements are dynamic systems. It is a memoryless system. No, there exists a capacitor has some memory. It is not a memoryless system, it is a memory system or dynamic systems. So causal system means response depends only on present and past inputs but not on future inputs. The statement is correct. It depends on present and past values of voltage source. So it is a causal system. Non-causal system means response depends on present and past but also on future inputs. So non-causal systems are anticipative systems that are physically non-reliable, whereas these causal systems are physically rela- realizable. The systems are physically realizable and non-anticipative systems. So there is a capacitor. All this inductor means differential term, and capacitor means integral term, and these terms correspond to energy storage elements. It is a dynamic system. So dynamic systems are systems having memory. Static systems means system without memory, that is memoryless system. So a system is static if output depends on present input only, but not on past and future inputs. All static systems are causal, but not vice versa. So given for the given statement, conclusion 2 follows. Conclusion 1 is wrong and conclusion 2 follows. Next question. A linear time invariant system is characterized by the system function h of z is z by z minus 0.5 plus 2z by z minus 3 will be stable for region of convergence mod z less than or equal to 3. This is a assertion. And reason is ROC does not include the unit circle for mod z is equal to 3. Let us see for different cases. So this is a given transfer function h of z. It can be written as 1 by 1 minus 0.5 z inverse plus 2 by 1 minus 3 z inverse. The poles of this h of z are located at z is equal to minus 5 and z is equal to 3. This is the location of poles for the given transfer function. Case 1. If region of convergence is mod z greater than 3. In this case, ROC lie on the outside of outermost pole, that is causal signal, and does not include the unit circle. Hence, it is an unstable system, causal unstable system. If ROC is in between 0.5 to 3, it includes unit circle, hence it is a stable system and non-causal signal. If ROC is less than mod z5, so this here region of convergence is mod z less than 0.5. In this condition, it doesn't include unit circle, hence it is an unstable system, and ROC lie inside of the innermost pole. Inside of the innermost pole, ROC does not include unit circle for mod z less than or equal to 3. It is wrong. For mod z less than or equal to 3, it includes ROC. So it includes ROC means it is a stable. So ROC includes unit circle. So that means it is a stable system. Only assertion A is true, but reason is false. Next question. What is the use of interpolation filter in digital filters? So this interpolation or upsampling, it is a process where increasing the sampling rate by a factor of L. So and this is done by placing L minus 1 equally spaced zeros between the pair of samples. So this is called upsampling or interpolation, increases the sampling factor or sampling rate by same factor. So this upsampling is done by placing L minus 1 equally spaced zeros between the pair of samples. So this frequency spectrum of upsampled signal or interpolated signal with a factor of L consists of L minus 1 additional images of input spectrum. These L minus 1 images are due to addition of L minus 1 zeros between successive samples. That is, inserting L minus 1 zeros between successive samples results in a signal whose spectrum is an L-fold repetition of input signal spectrum. Next question. So, which of the following affects the transport of charge carriers in a semiconductor that generates diffusion current? So, diffusion current means the current without the influence of electric field. There is no electric field is applied. The non-diffusion current means, first see what is diffusion. So, the non-uniform or uneven distribution of doping of charged particles in a semiconductor results in movement of charge carriers, that is electrons and holes, from a region of higher concentration to region of lower concentration. This process is called diffusion. So when charge carriers move from one place to other place, this movement of charge carriers will contribute to a current. Movement of charge is nothing but current. So charge carriers are moving in a particular area, it constitutes a current. Current per unit area is that current is diffusion current. This current is diffusion current. No electric field is applied and no potential or no electric field is applied. So this diffusion current will flow only because of uneven charge distribution and no potential, no external field is applied. So diffusion constant is a measure of how charge carriers move from higher concentration to lower concentration. Let us see the expression for electrons and holes diffusion current. So electron diffusion current is represented by Jn is equal to plus Q dn by dx, where dn is diffusion constant. This diffusion constant is a measure of how charge carriers move from high concentration region to lower concentration region. Measure of charge carriers from high concentration to low concentration region. Next, hole diffusion current Jp is minus q dp by dx, where n and p are concentration of electrons and holes, and dn by dx and dp by dx is the variation of hole concentration with respect to distance and variation of electron concentration with respect to distance. Next question. Okay. So dn mu n dp mu p are related as, so from Einstein relation, at a constant temperature the ratio of diffusion constant to mobility is constant. It's a constant value. So where dp and dn are diffusion constant for holes and electrons respectively, and this diffusion constant is measured in meters per second. Mu p mu n are mobility of electrons and holes respectively, and the units of mobility is centimeters or meter square by volt second or centimeter square by volt second. So from this expression, dp by mu p is equal to dn by mu n is equal to kt by q, that is t by 11600. Kt is Boltzmann constant, t is a temperature in Kelvin, q is a charge of a particle, and its value is t by 11600. So statement option 1 is correct.